Okay, this video tutorial looks at the mathematical strand of networks, and more specifically we're just going to focus on some network basics such as how to draw one and the kind of terminology that we might encounter when looking at networks. So the first thing we're going to talk about, well, what is a network? So a network is basically a way of showing the relationship between things or how things are connected to each other. And you've probably seen this on maps, as in our example here, but there might also be a diagram like a family tree that might show how things are connected as well. So these things that we're talking about are represented by dots or points, so that's really important that you remember that, and that the connections of these things are represented by our lines. So the things are the dots or points, and the connections of how they are connected is represented by lines. So an example, if you look at this map that we've got a few towns here. So the towns are the things and they're represented by our points. All right. And the relationship between them, or the way to get from one town to another, is represented by the lines. So we can see how we've got some lines here that I'm kind of going over in green, and that's the connections. So we're going to look at some terminology of these of networks, and I'd probably encourage you to write some of these at least key points down, and I'll try and explain what's going on with the diagrams that I've got on here as well. So like I said before, the points of a network are the things that we're interested in, and we call them nodes or vertices. All right, so nodes or vertices, and you can see by our diagram here that the little red dots are the things we call the nodes. If the lines on our network do not show a direction, okay, so it's important they don't have an arrow, then we call them edges. Okay, and we can see that on this diagram here, where it's actually pointing to the line connecting the nodes. There's no arrow, so we call that an edge. However, on our next example, you can see that it does have an arrow. So here we've got lines having an arrow. We call these an arc because the arrow is showing a specific way that this relationship occurs. And then sometimes the lines on our network have weightings. Similar to the previous example I showed you with the map where it had kilometers going from town to town. So these weightings allow us to understand or represent things such as the time between, the distance between, or the cost between. So that's an example of, and something important to note is that the weightings may actually determine which way or which path we're going to take on these vertices and these networks. Now, it's important to understand the difference between a connected and a disconnected network. Now, obviously, connected network is where you can travel from one node to all the other nodes, okay? And here's an example of a connected network, all right, here, where you can see there is a clear path going through all of the nodes. In our disconnected network, all right, I'll highlight disconnected in green. We've got a disconnected network here, which shows there are some relationships between the nodes, but not all of the nodes are actually connected to each other in some way. So that's important to understand the difference between connected and disconnected. The next thing is the difference between a path and a circuit. Now, a path is when we start at one node and we end at another. So, for example, in our diagram here, we're starting at A and we're finishing at D. That is a path because we're starting at one node and ending at another. Whereas if we're looking at a circuit, the circuit actually starts at one node, travels around to other nodes, and then ends up back at the original starting node. Okay, so a path starts at one, ends at a different one. A circuit starts and finishes at the same node. And the last thing we're going to talk about is a spanning tree. Now, a spanning tree shows the connections of a network but doesn't have a circuit. Now, remember, a circuit is starting at one node and finishing at the same node. All right, so we've got a spanning tree here because it does have connections because all the nodes are connected. All right, so it's a connected network, but it doesn't actually have a loop, all right, or a circuit. In our second example, it contains a circuit. The circuit is this here. All right, that's a circuit because we can start and finish at the same node. So therefore, that's not a spanning tree. And this last example, we actually have a node that's not connected to anything. All right. And if it's not connected to anything, then it's not a connection on the network, and therefore it is not a spanning tree. So here's an example question that you might have to answer. It says, draw a diagram which shows the local area network of 3 computers connected through a server to a printer and scanner. Well, you can see the example. We've got our computer 1, computer 2, and computer 3 are all separate, but they are all connected to the same node, which happens to be the server. And then once it goes through the server, because it says through a server to a printer and a scanner, we can go either way here and here, and there's our diagram of our network. So I'd like you to have a go at a practice question of basically trying to draw a network to talk about the access of the rooms on the first floor of this 2-story house. So basically you want the things that we're looking at, the nodes are going to be the rooms, and the path or the connections are the way of going from one room to another. All right, so please feel free to pause the video, have a go. Once you think you've got the right answer, continue it, and we'll see how you went. Okay, so let's have a look at the answer for our practice question. Basically, we had to try and draw a network that connected the different rooms in the house. Now, remember that I said the rooms were the things, so every room should have a node. As it says here, the rooms are the nodes. And then the doorways going from one room to another are the edges. And remember, we didn't have a direction saying you had to go from the lounge to the dining room or from the dining room to the hall. So remember that we don't have to, these are all edges because they don't have a direction. All right, but the connections would have been going from any room you can to any other room. So for example, obviously when you're in the lounge, you can go to the dining room or you can go back into the hall. But if you wanted to get to bedroom 1, you can't go straight from the lounge to bedroom 1. So you have to go back into the hall and then back into bedroom 1 that way.